Two quick examples of completing the square, but with kind of all the trimmings, making sure that I'm including the kinds of complications we can get. So two variations we've done. One is just when we've got an expression. It's not in an equation. We're not solving it. We're just rewriting this expression. And then we're going to do one in an equation context as well. So when this first coefficient is not equal to 1, you need to factor it out. And I like to say I'm creating a little sandbox here. Oops, that's not what I meant. That contains all these stuff with x's in it, all the stuff with the variable. And certainly a -3 just factors out, and then this leaves a 1 here. That's the point. And then when I factor a -3 out of a +10, that becomes a -10 thirds. So watch out. This sign is often tricky. The -17 is just going to hang out for a couple steps and not do anything. Now, like I said, these big parentheses here make a little sandbox, and then I'm going to do the key completing the square step inside that sandbox as if this is the entire problem. And I'm going to do what I always do, new parentheses with a different role, x minus, and then it's going to be half this number. 10/6 would be one way to say that, but that simplifies down to 5/3. So make sure that's kind of convincing to you. And all squared, okay? So the way I like to think about it is that will match those two exactly. That'll give the x squared. 2 times x times -5/3 will give you the -10/3. But I just accidentally added the square of that number, and I don't want it. And so I fix what was going to be a mistake right away by subtracting it off, right? So this stuff, if I expanded it back out, I would see, if I did it carefully, that exactly equals this stuff. And if you want to do that as a sidebar to double check you're doing it right, that is totally fine, but it's not really necessary. Okay, so now the rest of it is just cleanup. The main thing is just to get this constant together with this constant to make one constant to simplify it. The way that I need to do that is I need to break the sandbox. I noticed that at that point, some people think, oh, I'm trying to put the -3 all the way inside here and manipulate this and do it. No. This is exactly what I want. That's the whole core of what I'm trying to get in this method. And I'm just putting the -3 next to it. But when I distribute that -3, I'm also going to put it on the 25/9. And you can do these steps a little quicker if you want. I'm doing the arithmetic with more steps than is absolutely necessary. But I did go ahead and cancel the minus and the minus to make a plus, okay? And then I can realize, oh, you know what, there's a little cancellation there as well. Don't write that as 75/9. You should always be looking for numerical cancellations. Okay, now I got two numbers to combine. It's just arithmetic, but it's arithmetic with fractions. So I got to put it over a common denominator. Okay, very close to being done. And so then -26/3. Okay, so that's a little more complicated. We've got, this was a fraction. This is hanging out in the front, and that made this first prep step necessary. And then this was a little bit of fraction arithmetic. It's not fundamentally different, but it sure does feel more complicated. And that's it. So for that, if you're just like, somebody asks you, just rewrite this in the completed square form, or we're going to call this in the spring, we're going to call this vertex form, because we're going to use it to graph parabolas, then that's all. Okay, now what if we wanted to be in the equation context? Okay, so now I'm going to keep writing the equals 0 on the right-hand side for a few steps, but not do anything with it. But what am I first going to do? I'm going to factor out a -2. The constant is not the crucial part, so you don't want to include that. You just want it to hang out for a few steps. And notice here I factored a minus out of a minus, and then that becomes plus. Again, easy to get that sign wrong. That's with even in quite advanced students, they tend to get that wrong, or often. Okay, so now this is the sandbox. And then inside the sandbox, I do completing the square on x squared plus 4x. I take half of 4. That's the core of what I'm going to be doing. But that would give me the x squared, check. X plus 2 times 2, check, 4x. But that gives me a plus 4 that I do not want, and I kill it off. equals 0 equals 0. Oh, I don't want the equals there. Whoops, I'm just putting the right place. There we go. That was probably confusing about where that was showing up on the screen. Okay, so I've done completing square step. The rest of it, as in the previous example, is just cleanup. So I'll copy, and so I'm going to break that sandbox. The -2 just shows up right next to the x plus 2 squared, and then I'm just distributing a -2 times a -4 is a +8. Now finally, the 3 actually combines. +11. Okay. Now I could try this a little bit so that this wasn't a fraction. Remember in that previous example that turned out to be fractional. It totally could in this context, but I didn't contrive it too much because I wanted it to be a little complicated. Oh shoot, I think I got my signs wrong. No, I'm good. I'm good. I'll tell you what I was worried about in a second. Okay, so now, given that I am in the equation solving context, and that I've put it in completed square form where there's only one x, now I just move things over. So I got momentarily worried that that was going to be a minus, but my subconscious was not remembering, oh, hey, I don't just square root both sides here. This -2 is on the outside. And so I first need to divide by that 2. That's really crucial. You need to all do this stuff in the right order. Order matters. So we need equals. Okay. Only once you've divided by that factor. Of course, we usually call that a, right? What usually goes in front of the x squared. We have a name for that. That's a. When that's not equal to 1, that cruise through the start of the entire every one of these steps. It's gonna be here, and you need to deal with that first before you square it. Luckily, that also turns this plus. Which means that we will get real answers. So don't forget your plus or minus. And because neither of these has a perfect square factor, we're not going to be able to do much with that. I'll show you one thing we can do with that in a minute. And we're just about done. Now, sometimes people don't like, for pretty good reasons, sometimes people don't like roots in denominators. So I could write that as root 11 over root 2 as well, right? So that's an important fact about algebra. Is root a over b is root a over root b. Okay, but sometimes we like to not have that root in the denominator, and so what we do is we rationalize. So again, this is another just cleanup step. I would not consider this incredibly deep, but if it's a skill that you don't have, you definitely need it, because sometimes it is necessary. The reason for multiplying by root 2 over root 2 is that makes this nicer, because that makes it just a 2. Oops. And then that all combines to be root 22 over 2. Okay, so that might be the sort of more preferred form. Honestly, a lot of the time, that's just fine. But it's good to know that kind of manipulation.